Hello everyone. Today I'm going to share about a little trick on how to modify Airflow task ordering. So let's take a look at how Airflow determines which tasks that should be submitted to the executor. As context, I'm using Airflow version 202 here. I guess it should be fine for those who are required to still using version 202 and somehow is not able yet to upgrade to the higher version. So starting with a list of task instances here, with various states such as schedule, success, running, and so on and so forth. Afterwards, Airflow will fetch task instances whose state is schedule only. Next, Airflow will take only several task instances based on the total slots available. In this case, let's say the current total slots is 5. Therefore, only the first 5 task instances that will be fetched by the scheduler. Next, those task instances are classified into the corresponding pool. For instance, task instance 1, 2, and 3 belong to pool A, meanwhile task instance 4 and 5 belong to pool B. Next step, on each pool, the task instances will be sorted based on priority weight in descending order and based on the execution time in ascending order. For example, on pool A, after sorting, the first task instance will be the third task instance, and the last task instance will be the second task instance. After sorting process, Airflow will evaluate which task instances are possible to be executed on each pool. Note that each pool has its own available slots. This example shows that on pool A, task instance 2 cannot be processed further since the available slot for pool A is only 2, meaning that the maximum number of task instances on pool A is 2. Different thing goes with pool B. Its available slots is 3, meaning the maximum number of task instances that can be included on pool B is 3. And therefore, these two task instances, task instance 5 and 4, can be processed further on pool B. Last but not least, the final step is just returning qualified task instance to be run by the executor. So, what's the possible issue here? If you take a look at the task instance selection logic, you may notice that assigning higher priority weight would not be that effective. We expect that task instances with higher priority weight should be executed first. However, since the scheduled tasks are picked randomly, we might end up with task instances with lower priority weight. In this example, we get task instances with priority weight 1, or the default value on Airflow. Meanwhile, there are other task instances with higher priority weight, such as task instance 96 until 100. In this case, the priority weight of 10, 30, 50. However, the task instance 1 until 7 has only priority weight 1. In addition, you may also notice that Airflow stored the task instances based on priority on this tab, right? However, this process is performed after retrieving all scheduled task instance, meaning the task instance on each pool will have lower priority weight, or in other words, the priority weight that should be picked up is not as what we expect before. So how's the solution then? The task selection process is controlled on a file called schedulerjob.py. You may visit the file on the Airflow's repository on GitHub. To make it short, we can add the sorting logic on this line, the one with the red color. So it instructs Airflow to sort the task instances based on priority weight first and execution time. If Airflow finds 2 records or 2 task instances with the same priority weight, then Airflow will use execution time as the second condition. So in this case, since the ordering or sorting will be performed in ascending order for both priority wait and execution time. But because we add the negative sign in front of the priority wait, the task instance with higher priority wait will be picked up first. So as bonus, let's take a look at the GitHub repository for the scheduler job.py. So the method that controls how Airflow selects task instances to be submitted to the executor is executable task instances to queued, right? In this method, you can find clearly all the logic or steps that Airflow take to select the relevant task instances. So for example here, Airflow first will determine the maximum number of task instances to fetch. In this case, it compares the maximum task instances, which is provided as the parameter of the method, and the number of free pool slots. And afterwards, Airflow will execute this query, which basically fetch all task instances with state scheduled with deck run, which is not in pause tab, or deck run, which is not in backfill job type. And afterwards, Airflow will map each task instances to the corresponding pool. So in this case, there's a variable called pool2task instances, which is a dictionary of list, and each pool will have its own list of task instances. And afterwards, here's the loop where Airflow processes its task instances in each pool. So for each pool, Airflow will calculate the available slots for the pool, and after getting the open slots or the available slots, Airflow will sort the task instances on that pool based on priority wait and the execution time. And we can see here that Airflow compares the pool slots required per task instance with the available slots. If the required pool slots is higher than the available slots, then Airflow cannot execute that task instance. If it goes well, meaning that the required pool slots is able to be accommodated by the open slots, then the task instance will be appended to a list called executable TIS, right? And the open slots or the available slots will be reduced by 1 because that pool slots is already taken by the task instance. And at the end of the method, we can see that the executable TIS or the list of qualified task instance will be returned by Airflow to the executor. Well, I think that's all for this video. Hope it helpful for you guys.